All right. Hi, everyone. Thanks for joining us today at the inaugural episode of DocumentDB from the Dining Table, Episode 1. I'm your host, Chad Tyndall. I'm a NoSQL Specialist Solution Architect here at AWS. So I help our customers design and work with NoSQL solutions like DocumentDB and DynamoDB. And I'm joined today by my guest who needs no introduction. Joe, why don't you go ahead and introduce yourself?
Hey folks, name's Joseph Zork. I lead product for DocumentDB. Excited to be here with Chad and looking to have a little bit of fun.
Yeah, this should be fun. We're just two guys sitting around the house talking about DocumentDB, how to use it, how to avoid some common pitfalls, and we'll dive in and do some demos here in a little bit. Our episode today is sponsored by the Netflix TV show Cobra Kai. They've asked me to wear this mask during the presentation. What's that, Joe? Oh, we don't have a sponsor? No, I just really love the show Cobra Kai on Netflix. Everybody should go watch that when you have a chance. It brings up the 80s nostalgia of Daniel LaRusso. Okay, let's dive right in. Uh, we're going to do a demo in a little bit. And so what I want to do first is actually go kick off some clusters. So you see how I do that, because it does take a few minutes for them to start. So I'm going to spin up a DocumentDB cluster here in the console. We'll just call it Twitch. We're on Twitch. I'm going to make it a small instance, t3.medium, since we don't need it to be very big for our demo. Normally in a production cluster, you'd have 3 nodes, but since it's just a demo episode, I'm just going to have 1 node. I'm going to be very creative with my usernames and passwords. Password is literally password. And click open some advanced settings. I don't need to enable deletion protection because I'm for sure going to want to delete this when it's over. And I need to open up the MongoDB port 27017. So I have a security group for that. All right. So I'm going to kick off that cluster creation. And I'm also going to spin up an Elasticsearch domain because I do want to demo. Elasticsearch as well, integration with DocumentDB. So we'll call that domain Twitch as well. This 1 node again. I don't need a bunch of high availability here for this demo. I don't need any extra storage or anything like that. Okay, it's going to be in my default VPC. We'll put it on, just pick a random private subnet that works in my VPC. And I do need to enable both. I want to enable both HTTP and HTTPS. I just don't want to be fighting with certificate stuff. Normally, of course, in a production cluster, you'd want to use HTTPS for that. And for access, I'm just going to allow open access to this domain since we're just using it as a development cluster. And I don't need to enable fine-grained access control, which when I disable that, it allows me to turn off the requirement for HTTPS. And okay, I'm going to go kick that off. Now that's going to take 10 or 15 minutes in the background to start these clusters. I can see they're both in the creating state. So let's go back in and we'll revisit that here in a little bit. Also, I want to give a shout out to our friends at our sister channel, Containers from the Couch. They run I believe it's a daily Twitch stream where they talk about containers. And the reason I want to give them a shout out is because they helped me a lot while I was planning the preparation of this episode. I wanted to spin up some load generators. And in the old days when we wanted to spin up load generators, we might just instantiate 10 or 20 or 50 EC2 instances and have those running various scripts or something like that. And then we modernized a little bit and we would run load generators in an EMR cluster that just had 50 nodes in it, doing some giant map task to generate load against the database. But Brent over at Containers from the Couch walked me through how to use Copilot. And AWS Copilot is a product which was launched, I guess, in July, so not that long ago. And it basically allows you to very easily spin up containers in Fargate. You don't have to go through the process of creating an ECS cluster, adding nodes to it, all of that. So if you have a load generation, just like a Python script or something like that, and you want to run 20 or 50 instances of it, Copilot makes it super easy to Dockerize that load generation program and spin up as many instances as you want really in Fargate. And we're going to do that. And again, that takes a little bit of setup. So I want to kick that off in our console here so that the CloudFormation script can run in the background. So the way that works is I'm going to initialize an app called Twitch with a service called a DocDB Replicator. Okay. And this is the command line for it. Okay. So essentially what's happening is I'm spinning up a backend service. It's going to run in Fargate. Right now, the Copilot assumption is that your service is a network service and it has to be listening on a port. That's also how it checks to make sure that the service is up. So even though my load generation script isn't really listening on a port and accepting connections, I am telling it to do that and just ignore any connections that come in on port 5000. Otherwise, the Copilot system would just not recognize that my service actually started. So that's what's going on there. So this is going to run in the background a little bit. And it's you can see what it's doing. It's going to, if I pulled up CloudFormation, you'd see it spinning up some CloudFormation templates to sort of get all this going when we create our demo later. Okay.
Chad, did I totally miss the Cobra Kai sponsored part of the event?
Well, no, I have my mask here. I did bring it up, but
yes, perfect. Yes,
yes.
Small technical difficulties, but good to see that our friends at Cobra Kai Dojo Studio are helping us out today with broadcasting. So
absolutely, I was actually a fan of the Cobra Kai show when it was still YouTube before Netflix had picked it up. So I've been telling all my friends about it, and everyone was like, "That's stupid. That's stupid. I'm not going to watch that. It sounds dumb." And of course, now with the COVID lockdown, the Cobra Kai hit, I think, the #1 show on Netflix. So all the haters came around, which is happy.
It's good. I watched it with my son. He loved it.
Oh, that's great. Yeah, I watched all of the Karate Kids with my boys once a couple of years ago. We went through and did all of them, including the Hilary Swank one and the one with Will Smith's kid in China. So it was fun. Jackie Chan. All right, look, I would give a brief intro to DocumentDB just because we might have viewers who have never heard of or used DocumentDB before. The purpose of this Twitch show is not to go just give an overview, but I just have one slide for anybody who's new to the service. It is a fast, scalable, fully managed MongoDB compatible database service that runs in AWS. So it can serve millions of requests per second. It scales in 2 dimensions, both for compute and storage independently. So you can scale out to have 15 read replicas. That's how you sort of get the ability to serve millions of requests per second. There's really no limit to the amount of backend storage that you can use. I mean, there is some theoretical limit, but it scales out automatically without you having to come scale out the storage for you. It's all managed by us, so you don't have to go through hardware provisioning, rolling upgrades of software, upgrading Linux kernels, dealing with backups. It's all automated, and it is compatible with the MongoDB 3.6 APIs. So essentially you use the same clients that you would use to talk to that system to talk to DocumentDB. And Joe, I'll see if you have anything you want to add here.
No, that summarizes it pretty good. Yeah, I think one of the unique things that we did at DocumentDB is we built it on a pretty unique distributed storage architecture. And I think in subsequent episodes, I think it'd be good topics to get into, what is that architecture, kind of deep dive. I think we should get, one of our principal engineers to join us on the show and talk about some of those innovations. But as Chad said, that's it really helps us do a lot of things, and especially scale that the customers really care about in ways that are pretty novel and pretty quick. So we're looking forward to that, and I think that'd be a good topic for a future episode.
All right, we did have a comment from a listener from Brent from the containers team did tell us that Copilot is going to add a feature so that jobs don't need a listener port in the future. So that's just a little workaround we're doing right now, but Brent is confirming that they'll fix that, and you heard her here first. Thanks for that exclusive, Brent. All right, yeah, like I said, we don't want to spend too much time. We don't want to spend too much time just going on the background of DocumentDB, but if you don't know that much about DocumentDB and you'd like to learn more, there's numerous sessions and hands-on labs you can run through from reInvent last year. I'll share these slides. I'll put the link up later, and or you can just go to the blog post that's at the top, or Google DocumentDB 2019 reInvent. I'm sure you'll find Joe's recap blog post. And if you feel free to watch these if you need some more background on DocumentDB. Well, that's as much as we're going to say about that. The point of this show is really to dive in and get some behind the scenes looks at what customers are doing, problems that they're hitting, pitfalls that they're commonly running into, and see how we can avoid them. So I spoke with our DocumentDB support lead earlier this week and asked him what the most common support ticket question, things like that is coming in from our customers. And he said that the most common problem right now is customers running into this issue of exceeding their connection limit. Now, to simplify things, a connection in DocumentDB is really just a TCP socket from your DocumentDB client to a DocumentDB instance that you can send queries across and send data across. And every DocumentDB instance size has a different connection limit. So, for example, the T3.medium instance that I just spun up in the background is going to have a connection limit of 500. And if I exceed that number, if I spin up too many application clients, for example, and I go to hit 500, it's just going to cut me off at 500. And you can see I did that with my load generator. I spun up, I think, 50 instances in the background. 10 instances was doing about 170 connections. So definitely 50 instances put it over the 500 mark. And you can just see it just levels off right at 500. And at that point, any instances that weren't able to get a connection saw this exception stack trace that you see on the right side. And so this is fairly common because people will have, say, applications turned on with auto scaling or something like that, not really having understood how many connections each application instance or each Lambda function or whatever it is actually opens on their DocumentDB client. And then when the auto scaling event happens because their load went up, suddenly they're exceeding their database connection count, and things start failing. Users experience errors, things like that. It's something you want to avoid. So there's a few ways to avoid this pitfall. Really, the main way is, from a programmatic perspective, is to distribute your reads across secondaries. All right. So in your DocumentDB cluster, certainly in production, you're going to have more than one node. The one node will be elected to be the primary, and all of the other nodes in your cluster will be secondary replicas, which can only be used for reading. And so what you want to do is make sure that when you connect to DocumentDB with your connection string, you want to connect in replica set mode so that your client will automatically discover all of the nodes in the DocumentDB cluster. And ideally, you want to set your read preference to be secondary preferred so that your reads will be load balanced across the various read-only replicas that are there in the DocumentDB cluster. Okay, and those will be eventually consistent reads. Which usually works for most customers. But when you have an application which needs to do a strongly consistent read, you can override the default read preference on a query by query basis by, for example, just issuing a find command and passing a read preference of primary there, so that your read will always be sent to the primary, and it will be a strongly consistent read. All right. The primary is where writes flow through. So the primary always has the most up-to-date data. So you're guaranteed to get the latest copy of your query when you run it against the primary. Joe, you were going to say something?
Yeah, so a common question we get, Chad, is, why can't we have infinite connections, on all the instance sizes, and, why are there limits? Kind of, they use resources, it uses memory. There's a finite amount of memory on the box. And, at a certain point, like, it just runs out of resources on the instance. And that's why we cap limits on the number of connections. Now, we did quite a bit of work over the last few months to actually increase the number of connections or the number of connections and cursor limits. I just put the updated docs in the chat. In some cases, in some instance types, by 10x, by being much more efficient about how we use memory. But it's literally just a physical resource constraint problem. And that's usually what we see. It's hard to open up 100,000 connections on a 2-core box that only has 32 gigs of RAM. Like it eventually exceeds the capacity of the instance.
Yeah, definitely. I think a lot of people think of the cloud as being this sort of opaque, infinite resource, and And that is how we do want people to think about it generally, because you should always be able to scale up to meet whatever demands you have. But our capacity is finite at any moment in time. So these are real physical servers behind the scenes. There's only so many sockets a given instance can open up in a Linux kernel, for example, or whatever. So there are limits here. The limits are enforced, and those are hard limits. They can't be changed. You just need to, if you need more, you either need to add more secondaries, or you need to scale up your instance size to be able to support more connections, or both.
That's right.
Now, the other thing you can do to prevent yourself from falling into this trap is to create a CloudWatch alarm on your instances. And I have a slide about that, but I think demos are a little sexier. So if I go into my DocumentDB console, I can see that I have a couple different DocumentDB databases here. I spun up 3 different ones for having one instance of my load generator, 10 instances, and 50 instances. So if I just go look at, say, the instance that has 10 clients running, and I go into the monitoring tab, I will see when it loads. I have 3 kids who are doing school from home today, so I'm sure their Zoom sessions are chewing up a bit of my bandwidth. Wow. I think StreamYard is my bandwidth too.
Oh, come on, CloudWatch metrics. You can do it.
Well, this is what you get with a live demo.
Hey, this is how we know it's real, Chad. That's how we know it's real.
Yeah, this is not fake here. This is for real. So we can see here database connections is one of the things that we monitor. And again, yeah, each of my instances takes up about 17 connections. So if I were to click on the hamburger menu here, view it in metrics, God knows how long this is going to take. Hopefully it's a little faster since it's just one metric. Maybe not. That was wishful thinking. Yeah. So I can see my
the internal optimist
here. I can see my database connection. Yeah, I'm always optimistic. I expect the best from everything, and so I tend to leave my life disappointed a lot of the times. There's a little button here. It looks like an alarm bell. So if I click that, I can go just launch an alarm here, and I can obviously the metric name is database connections. The identifier, okay, for that cluster is this. And I probably will just want to set a static value because I know that I looked it up on the table. The T3.medium has a 500 limit. So I'll just set a limit of 400. I want to get notified if this thing pops over 400 because I want to take a look and maybe scale up or something before I start running into problems. So that's definitely a good way to avoid this pitfall in the future. Absolutely understanding how spinning up new instances of your application affects the database connection count is critical. You do not want to end up in a situation where you scale up to support load that is happening in real time and it pushes you past the maximum connection count. So this is just an important thing to know. And if you have different database clients, sometimes you have a database client, which is the main application. And sometimes you have secondary clients, maybe analytics jobs or something like that. Which is working behind the scenes and not part of your main application. You can actually spin up a replica instance just for them to use privately and give them that instance endpoint as opposed to the cluster endpoint so that their workload, even if they do spin up, say, 600 connections, it won't impact your production workload. They'll be isolated on their own replica instance, and any problems they cause will only affect them. So that's just a nice pattern you can use if you have other jobs. And you can spin up these replica instances anytime. Let's say you already have 2 replica instances in a 3-node cluster, and you need to run some batch job that's going to take a long time. You don't want it to impact things. You can spin up a 4th instance and use that for your batch job, and then delete the instance when you're not using it anymore. It'll go away. You'll stop paying for it.
And so the really nice thing about that, and this is where we kind of get some wow moments for customers, is regardless of your data size, and we'll talk about this in a future episode on the architecture, is that DocumentDB separates storage and compute into two different layers. So when you add a new replica instance, you're not copying any data. There's no EBS volume copy. There's no syncing between replicas. It literally just is the time it takes for us to spin up a new EC2 instance, lay down the DocumentDB bits, sync the metadata, and then your client auto discovers it as a new replica on the replica set. So, even if you have 10 terabytes, you can add a new instance to do, this kind of, load testing or add for more connections in about 5 to 7 minutes. And it's pretty slick.
Yeah, awesome. All right, so that's all we want to say on this topic. I do want to go babysit the demo setup in the background a little bit. No, I don't want to deploy a test environment. So the next thing I need to do to get Copilot running is I need to initialize an environment. An environment, you can support multiple environments. You might have an environment like dev, test, QA, prod, or whatever. So I'm just going to make this a dev environment. Use my default credentials. I'm going to use existing VPC resources. I could have it spin up new ones if I wanted to. I'm just going to use the VPCs and subnets that already exist. So I have 3 public subnets in US East 2. I have 3 private subnets in US East 2. Okay, and that's going to go run some more CloudFormation stuff behind the scenes. Let's see how our cluster creation is doing. Okay, that's good. So our Elasticsearch and our DocumentDB clusters are good to go when we get to that point. Nice to see. All right. So the next thing I want to talk about is some behind the scenes on an actual support ticket. This is a bit I'd like to cover every time we do this show because I think it helps people understand really at a deep level some weird problems that customers may be running into and how to avoid them. All right. So before we do that, I just wanted to point out that this is the architecture we were talking about earlier, where you have a distributed storage volume that's not directly attached to any of the instances of your DocumentDB cluster. The data that you store in DocumentDB is replicated 6 ways, 2 in each of the availability zones for the region. All right, so even if I just have a 1-node DocumentDB cluster, I'm still going to be getting 6-way distributed storage, so that there's very low risk that all 6 of those items would disappear and I would lose my data. Of course, there's backups and everything else as well to prevent that. But this is what's going. And then you can spin up additional replicas that are going behind the scenes that I can read from. Okay, and the replicas stay in sync by replicating memory pages across from the primary node. So as I'm issuing writes into my primary node, the primary is writing to the distributed storage volume, but it's also really pushing changes out to the replicas so that they see those basically as quickly as possible to reduce the amount of lag in the eventual consistency models. Is that accurate, Joe?
Yeah, you got it. So the replicas don't participate in the durability dance, right? They don't have to participate in quorum, but the primary does ship over the logs to the replicas. And if they have those pages in memory, they apply, right? Because that's what you want. You want to keep the replicas in sync with the primary. If they don't, the replicas just drop those logs on the floor because they have their own buffer caches. You can run independent workloads on them. So you're absolutely right.
Good. All right. So keep that in mind. And this is what we want to keep in mind, is that the pages that are in memory on the replica do get synchronized with the pages that are in memory on primary as writes come in. Okay, so a customer opened a support ticket, of course, so I won't tell you who the customer is. It's all anonymized, but this is real data from the support ticket. You can see that this is the engine uptime metric, which just tells you how long the DocumentDB instance has actually been running without rebooting or stopping or anything like that. And it was going up monotonically for a long time, which is really what you want to see in a healthy cluster. And then all of a sudden, it just dropped on July 14th, and it entered this sawtooth pattern where it would run for a little bit and then drop and run for a little bit and then drop. And obviously, the clients that were connected to that instance were experiencing, this is a secondary instance, were experiencing connectivity issues, problems, failures, etc. And so, of course, they opened a support ticket, and we wanted to dive deep into that. All right, if we start looking at other CloudWatch metrics that are going on and see if we can correlate other things with this problem that we're seeing, we see that at the same time on July 14th, the application started having database cursors timing out. Okay, so maybe this is related because they went for, this metric was 0 and suddenly it went up to 1, at the same time that this other problem started happening. And so that gives us a clue that maybe these things are related to each other. All right, now earlier we were talking about connections, which are just TCP sockets to the server, but this is about cursors, and cursors are very different than connections. Cursors are really a logical concept that exists server side, and when you run a query against DocumentDB, the database opens up a cursor. It holds things like the result set from your query in memory, and so that you can iterate through your result set. Imagine you ran a query that had a result set that was like 10 terabytes or 100 terabytes, something very large. Well, you're not going to ship that whole 10 terabytes back at once before you start processing it in your application. Your application is going to get a few of those results, process them, ask the server for more. It's going to get more, ask the server for more, and keep paginating through them. And it does that using this cursor. So essentially, you iterate through the result set on the server side using this cursor. And so the cursor does consume memory on the server side and other resources. Okay, so you really want to use this cursor, iterate through your result set as quickly as possible, and then close it to free up the server side resources. All right, so that's really what a cursor is. Okay, it's the construct that allows us to access the data that was returned from our query. So keep in mind that this DocumentDB instance is keeping the replica instances in sync by replicating these pages. So a cursor being idle for too long on a replica can lock that page. And so while a cursor is iterating on a page, it will lock that page and prevent it from changing. All right, it'll temporarily block the replication process. And if a replica instance falls too far behind, it's going to reboot itself to force a resync process because it doesn't want to keep falling further and further behind and never be able to catch up. All right, so it's really protecting itself. And that's what was happening in this case, is that the customer had some application change which ended up having idle cursors partway through iterating a result set, and they let it be idle for so long that the secondary ended up rebooting itself to force a resync. All right, so this is just not a good state to be in. It's really something that can be fixed by code. All right, so one way to fix that, there's a couple things you can do. There's a max time in milliseconds that you can give when you run a query, and it's good to do that, certainly. So you're basically setting a timeout. There's some examples if you're doing it in the console, or if you're doing it in Python, for example, you can set this max time ms parameter 10 seconds or 5 seconds, whatever you want to do. But most importantly, you want to make sure you always close your cursors when you're done with them, iterating through the result set completely to the end. If you call get next until you're done, it will close the cursor automatically as soon as you reach the end of the result set. Okay, so that's how you can fix it in your code. There's also things you can do as an administrator of DocumentDB. Of course, there's an alarm on database cursors timed out metric. That's what we saw in the graph a couple slides ago. And you can also detect operations which have been running for too long. So let me just do a demo here real quick. If I go to my IoT generator, and so this IoT generator is running in the background. If I run a shell to talk to DocumentDB, I can see my databases. There's an IoT database. I can see the collections that are in here. So I can do a device data.count. Let's see, I want to make sure this is actually running. All right, so yeah, this load generator is inserting documents. If I want to find one, and I can just see what it looks like. Basically, this load generator is inserting, something about a device identifier. There's a timestamp. There's a status of the device. There's a name of who the operator was, and there's a location. Just a small payload to represent some IoT sensor data. All right. Now, if I want to, I can actually spin up a cursor to search for, say, all of the entries which are in the active state. All right. And so then I can start iterating that cursor by calling cursor.next, so I can see what that looks like. And I can iterate on some of these. Now, keep in mind, the cursor is being held open on the back end by the server. So if I want to see any long-running operations which are on my server, I can use the aggregation framework to do that. Essentially, I'm going to interrogate the current op here. and I want to look for cursors which have been running for more than 10 seconds, let's just say, since it's a demo. I can see that this operation, which was my query on the device data field, looking for things that are active, okay, it's been running for 16 seconds. And maybe that's too long. I don't want it to run that long. So what I can do is I can kill that op using the op ID. Where is it? Op ID here. Okay. All right, and now I've killed that op, and if I try to keep reading from the cursor for a little bit, but eventually, because that's been in memory, but eventually it'll tell me that I can't do that anymore. So that operation has been killed, which I can verify by, it's not running anymore on the server side anyway. All right. Joe, anything you want to add to that?
So current op is really good to see the current state of the service, right? I think what we see, like if we kind of go back at this operation and it's like, okay, well, how do we know it was running, 1 hour ago or 2 hours ago? One of the things that we have, one of the features I have in the service is called the slow query logger, which allows, for queries that do, run for a very long time. You can set a threshold and say, hey, everything that runs over, a second or a minute, depends on the context of your application. We want to actually understand what query that is, what the IP address it's coming from, and then ship that off to CloudWatch logs so we can monitor it. So that's another way. If you kind of balance out, if you think about, current op is a point in time, slow query logger is kind of that longevity or kind of time series, if you will, to help capture some of these long running queries, to give you some more insights into what's going on at the system. And, you can set a sampling frequency and all kinds of fun stuff, but it really does help people keep track of these things over time versus when they, versus not waiting until after they hit an operational instance, say, ooh, I do have a query that's not using an index. Let me go, try to figure out, should we add an index? Should we do something here? Why is this query running so long? So just one complement to current op.
Absolutely. And yeah, Brent does want to point out that this was a really nice experience for the customer from the support point of view. They opened a ticket. We helped them dive into it, really helped diagnose the problem. And so this is definitely something that is nice to have if you have a relationship with support here. All right. Okay. Good. Let's move on to a few migration tips and tricks that I wanted to talk about. Obviously, some people are coming to DocumentDB from other databases, and some people are starting fresh with a brand new application with DocumentDB. So sometimes people want to come here. Usually we go through a planning process to discover what is your application, what is the type of workload that it's doing. Is it read heavy? Is it write heavy? How many writes per second? How many reads per second are you doing? How big is the cluster that you're using now? How are you doing testing? You want to think about all this stuff. How do you do monitoring? Obviously, the way you monitor a cluster in DocumentDB is a little bit different than it would be if you're running something on premises. So that's something that's going to change. Something to keep in mind here is that you'll want to figure out how many reads you're doing, because each instance is capable of serving some finite number of reads, and we sort of know behind the scenes what instance size is capable and what read capacity each instance size is capable of doing. You'll want to think about backups and how long you want to keep backups for in terms of retention. You want to think about what your working set looks like. The working set being the portion, the subset of your database that you need to keep in RAM so that it's fast and accessible all the time. So that's something you're going to want to think about as well as the vCPU count. Different instance types have different CPU counts, of course. So there's really 3 different approaches that you can take to migrate to DocumentDB. The easy way and the fastest method, which has also the highest downtime with it, is to really just stop writing to your application database that you're using right now. Okay, so once you stop writing to it, then you can start the migration process without worrying about losing data or keeping track of changes that have occurred during the migration. All right, so what you want to do first is dump your data and indexes using the utilities that are available to you, And you want to pre-create your indexes in DocumentDB. When you add an index to an already existing collection in DocumentDB, that background index build is single-threaded, so it can take a little bit of time. If you have a lot of data, or if you import, say, 10 or 50 terabytes of data, then doing a background index build can take a little bit of time. Whereas if you create the index while the table's empty, then as you write to your instances, of course, then that task is multi-threaded, of building the indexes in real time. So you really want to pre-create your indexes. Then you can restore your data with the restore tool after the indexes are created. Once the data has been restored, you can restart your application and you're good to go. And this works really well if you have an application which has the ability to take some downtime. Maybe you have maintenance windows already scheduled or something like that. So it's very straightforward.
Yeah, and I can't stress the create the indexes before loading, say like 10 terabytes of data enough. And the reason being is, like, imagine, you're loading data on a 64 core machine. You basically have 64 cores that can do parallel inserts. If you're balancing, you say Mongo restore, and you're parallelizing the number of workers. So like that, and you think about that parallelization, 64 inserting threads versus one background process trying to do a background index build and not interfere with foreground writes. It makes a big difference. So that one we can't stress enough. It's a really good best practice.
Absolutely. All right, so obviously there's applications which won't want to take downtime, and of course doing a backup and restore without taking downtime means that you need to keep track of any changes which have happened during the restore process. And so in order to do that, so what we'll do here is we'll leave our application still using the source database. We'll still go pre-create our indexes because that's really important. And then we will use the AWS database migration service to do a full load and replicate the data into DocumentDB with change data capture. So the DMS service task can actually tail an op log and write any changes as well into the target DocumentDB cluster. All this is happening. So this is the slowest method. And we say it's the slowest method because the DMS task as well right now is single-threaded in terms of reading from the source and writing to the target. So it will finish eventually, of course, and you won't lose anything. You can keep using your application. Will keep pointing to the source database that you have now. Then once the full load and replication is done, then you can take just a small, say, downtime. Okay, let any lingering changes quiesce through the system, and then restart your application pointing to DocumentDB. So the downtime that you have would be very minimal there.
And the rule of thumb for this one, we work with customers, is like 500 gigs and less is kind of like the size. If it's 500 gigs or less, the online approach works really well, and it's fast enough. And you start to have like multiple terabytes of data, then kind of the parallel load thing really matters, right? Like it really makes a difference in speed. And then there's implications on how, speed has implications on how long your op log size needs to be on your source. But that's kind of the rule of thumb between kind of, when you think about, you get to online and you say, hey, maybe we should seed this, which we're going to talk about next with an offline and do the hybrid. But that parallelization thing, Chad, we should fix that in DMS. I think we should fix that.
We should fix that. Is there any changes coming out for that, Joe?
Oh, maybe we've gotten some feedback from customers that they'd like that to be faster, and maybe we're just working on that.
All right. Well, there's some rumors circling here on Twitch. You heard it here first. All right. We just got a question from a viewer. Can we use DocumentDB for checkpointing to replace DynamoDB and Kinesis KCL? All right. So what Arjun SK15 is asking, there is a library called the Kinesis Client Library. It's used to consume data off of Kinesis and DynamoDB streams. And what the library does is it keeps track of its position in those streams by having some metadata that it stores in a DynamoDB table. So even if you're not using DynamoDB streams, if you're just using Kinesis streams and using the KCL to read it instead of using Lambda triggers or something like that, the KCL is going to use a DynamoDB table behind the scenes to keep track of its state and its position in the stream. All right. So the answer to your question is no. Right now, the KCL is still using DynamoDB. It is an interesting concept. Maybe we could modify the KCL to use DocumentDB for checkpointing instead of DynamoDB. Certainly no reason why we couldn't do that, but that's not how it works today.
Yeah, I think, Chad, this is kind of one of those interesting things is like Dynamo might actually be a better fit for this type of workload, right? If these are gets and puts, trying to understand what the last written time is, I think we could do that in DocumentDB, but Dynamo might actually be a better use case for this particular tool in situation.
It could. I can definitely see why people who are already using DocumentDB for other things and aren't using DynamoDB would want to, that this might be literally the only thing that they're using DynamoDB for right now. And so, having the option to switch it out to DocumentDB so that they don't have another service that they have to interact with that they're not interacting with right now could be nice. I see why someone might want that.
Sounds like an opportunity for a contribution.
Absolutely. Absolutely. All right. Now, there is one more thing we can do, which is a sort of a hybrid approach to avoid the problem right now where DMS is single threaded and can take a little while. So what we can do is we can do our pre-create the indexes, dump the data from your original database and restore that data. But before you do that, what you'll do is you'll enable DMS. After that's done, you'll enable DMS with replication mode so that essentially you're getting the best of both worlds. You're getting the multi-threaded restore process that we were using before, but you still have DMS actually keeping track of all of the changes from the op log for you so that when you're done, you can apply those op log changes into your DocumentDB cluster. So this is really it's still going to minimize downtime, but it's going to be more complicated because you're going to do a manual restore and you're going to use DMS just to keep track of changes. Whereas back here, we were using DMS to do a full load and replication with CDC mode. Here, we're just going to use DMS to do the CDC mode. We'll do the full load with the command line tools. So this is the most complex, but it is the fastest and will minimize downtime for you. All right, looks like he doesn't have any more follow-ups. So thanks for that question. By the way, anybody else is asking or watching, feel free to ask any questions that you want. We may or may not answer them, but you could ask them. Yeah, so that's really what I want to say about sizing. There is this index tool here. If you go to the AWS Labs under Amazon DocumentDB Tools, this is a tool that you can use to dump index definitions and load those into DocumentDB for you. It'll tell you if you have any indexes which are incompatible with DocumentDB. For example, geospatial indexes aren't something that's supported in DocumentDB today. So this is not an index that you could load into DocumentDB. So it'll help you analyze whether you have any situations like that you're doing something which might not be compatible when you load your data.
Also worth noting, DMS is kind of a many-to-many tool. So it's not just from other document databases. We see actually quite a few customers migrating from Oracle, SQL Server, other relational databases too. We had a really good talk with Finra at reInvent last year about why working with a document database was a lot easier for them than working with XML on top of inside of an Oracle database. So we do definitely see kind of this heterogeneous path as well.
Yeah, definitely. It's a polyglot solution. And of course, here in the NoSQL world, whether we're talking about DocumentDB or DynamoDB or anything else, we're all the time fielding questions from customers who want to get off their relational database and move to something that's more scalable, easier to work with from a programming point of view, all of that. All right, so the last thing I want to talk about is doing this demo of replicating data from DocumentDB to Elasticsearch. So the way we're going to do that is DocumentDB supports this feature called change streams. And, you can read more about that there in the manual. There is the AWS samples repo in GitHub, which I thought I had Pulled up in the tab, but I didn't. And inside of this samples repo, it's so much faster than CloudWatch. Inside of the samples repo is some sample code that shows you how to connect and query data, all of that. There's some templates for some sample cloud formation stacks. There's also this change streams subdirectory here. And what this is some code which will watch the change stream of your table and then forward any of those events, the inserts, the updates, and deletes to other services. It does support a number of services, one of which is Elasticsearch. Of course, that's a big one because right now DocumentDB doesn't support full text search. So if you want to do any sort of, complicated full text searching, um, typo correction, autocomplete suggestions, all those types of things that you usually want to do. Elasticsearch is really powerful for that. And so you want to keep an Elasticsearch domain in sync with your DocumentDB cluster so that your application can query one or the other, depending on what it needs to do. This tool will also allow you to send data from the DocumentDB change streams to Kinesis, SQS, Kafka, S3, or whatever. And so this is really the tool that you want to keep in mind right now. This is a sample tool that's published here in AWS samples. So you might need to change it to meet your purposes, whatever you want to do. But it's a really nice starting point. And I think maybe we can ask Joe. Other services like say DynamoDB or Kinesis, they have the ability to automatically trigger a Lambda function. Right now, DocumentDB doesn't support that, and so what you need to do is essentially run that yourself behind the scenes, tailing the stream, just like we talked about using the Kinesis client library to watch a Kinesis stream or a DynamoDB stream. You can use this library, which is kind of like a KCL, but for DocumentDB change stream specifically. So I was curious, are there any plans in place for adding a trigger in Lambda?
We get that feedback quite a bit, Chad, and we love working on things that our customers ask us to build and making these things easier. So there's probably a good chance. That we want to build this for customers.
All right, very good. Yeah, I imagine that's a common feedback.
It is
Yeah. So
very
for now,
common.
this is something. If you follow the guide that's here in GitHub, this sample code is really written as a Lambda function. And it shows you how to trigger that Lambda function using a CloudWatch event that runs, say, once a minute. So you can spin up this task once a minute, have it replicate everything from the stream, and then basically it'll do that process once a minute. And for what I wanted to do, I wanted to convert it into a long-running application, which I could run in Fargate. And so that's what I did. I created a demo here, DocDB ES Replicator. You can go to my ctendall/AWS-Twitch tree if you want to in GitHub and see this. But I basically took the Lambda function that was there. I stripped it down because I only cared about Elasticsearch. I didn't care about replicating to S3 or anything else for this. And so I stripped it down. I converted it from a Lambda function into just a standalone thing that can be run from the command line. Now, you'll see if you read it that there's two different threads. There's the socket thread, if you recall. Fargate right now, or Copilot at least, has a requirement that we be listening on a socket. So I do have a thread that just listens on that socket. It accepts it, and then we move on so that this can work. But then I also have a worker thread going behind the scenes, which is actually doing the replication, and it's basically running in an infinite loop, waiting for someone to send it a signal to exit, to terminate, and it's just running the replicate function and then sleeping for 10 seconds, just so I can actually watch the logs on the console and have a 10-second break. But probably in real life, you wouldn't want it to sleep for 10 seconds. You'd want your replication to happen as quickly as possible. All right, and so basically what it's doing is it's watching. We call this watch function. The watch function is what allows us to tail the change stream on my collection.
Hey, Chad, can you zoom in a little bit? Sorry to interrupt. Can you zoom in a little bit? I think we're having some issues with resolution, so I want to get that beautiful code in front of people.
Yeah, so basically this is just a loop which is going to watch the change stream, and anytime changes come along, we're going to forward that change. If it's an insert or an update, okay, we're going to publish that. We're going to call the index function on our Elasticsearch client. And if it's a delete, we're going to call the delete function on our Elasticsearch client. And that's basically what's going on behind the scenes. Anytime a change comes in, we're just forwarding that change to Elasticsearch. And I can run this from the command line. So let's go now that our clusters are up. Let's take our endpoints. I'm gonna need to copy these for usage here. We're doing it live. Fingers crossed. And I have an Elasticsearch endpoint here, which is running in my VPC. So all you hackers out there who want to hack the Gibson, can't do it.
Hack the planet.
Hack the planet. Oh God, I love that movie.
Chad, I feel like we have a lot of common themes on shows and movies that we watch.
Maybe we should start our own Siskel and Ebert Twitch feed here. We can do movie reviews too. All right. So what I want to do is just set up some environment variables here so that my code can access the correct endpoints. These are the endpoints that I was using yesterday. Okay, now source that, and I'm going to run my setup script, which just creates the database. It's very simple. If there's an already existing Twitch database, right now there isn't, but we'll drop that. The change stream, the change stream library code I was just showing you, it needs to do the same thing that our viewer was asking about in terms of tracking its position in the stream, so it knows what the last event that it already replicated to Elasticsearch was, so it can pick up from there the next time it runs, and so it does keep track of its state in a different table in the same in a different database called, I'm just calling it REPL. So that's where it's going to keep track of its replication state. And then the other thing I need to do is to enable change streams on my Twitch database. So that's what I'm going to do. I'm just modifying change streams and calling enable true. Okay. And then if I already have an existing Elasticsearch index, I'm going to delete that too. So I'll run this setup. Yeah, so that index doesn't exist already, which is what I would expect. So I did get an error from Elasticsearch, but that's expected.
Can you do some control pluses so we can a little bit bigger font size, please?
Oh, more? All right, I tried.
Chad, my old eyes. I don't know.
I feel you. Chad.
Yeah, I'm not a spring chicken anymore, man.
I did like 4 control pluses before I started. Is that better?
70 more. Yeah, I think. Yeah, that's
more.
better.
I
think that's good. I think
the 2 is the best I can do. All right.
That'll help my old eyes. Appreciate it.
All right. So, yeah, good. So, well, I guess I'll do that over here in one more window because I'm going to need a couple windows to get all this going. All right, good. So here's my shell. It's going. I'm going to just run. Let's see, activate. I've got to get into my virtual environment that has my Python libraries installed. So I'm just going to run the DocDB ES replicator. All right, so now my replicator is running. Now, the other thing I want to do is show you that I can access my Elasticsearch domain. It's running in my VPC. So in order to do that, I actually need to go through a jump box to access the Kibana instance on it. And so what I'm going to do is just SSH through my jump box. All right, and I'm going to forward port 80 from I guess I'll do some control pluses here. I'm going to forward port 80 from my instance, which is how I would talk to it. I'm going to forward it to 8080 on my laptop, just so I can hit that. And again, this is why I disabled HTTPS, because I don't want to be dealing with cert problems connecting to Kibana over HTTP on localhost and all this stuff, right? But if I can curl that, if I want to curl that domain, just to make sure I have access to it. Yeah. So I can curl that and I get back the Elasticsearch. And if I go to localhost 8080 and go to Kibana, I can see that I have access to the Kibana port. It's just tunneling through my SSH connection into my VPC. And so that's fairly straightforward. It's going to load. All right. So let's put some data in our table. So I'm going to use Twitch. Let's see if there's anything that exists. Okay, there's a demo table. If there's anything inside of it, there's nothing inside of it. All right, if I go to Kibana and I see what indices I have, I can see that there is a Twitch-demo index that already exists. I can search if there's anything in it. All right, there's nothing in it. It's empty. And so what I'll do is just run db.demo.insert. Okay. We're doing it live. I have inserted that item. You can watch and see. You know, it might take a couple seconds. Obviously, I'm doing this 10-second loop. All right, it did process that item. If I come back and search here, I'll see that this item does exist in my index, so I can see that the replication worked just great. And this is exactly what I want. It happened, I mean, it would have happened quicker if it didn't have the 10-second delay, but that allows us to actually see the logs go by. All right. And if I delete that item, all right, I can see that it's gone. We'll see that that item was deleted. There was a deleted result. Okay, and if I come back here and I'll do my search, I'll see that it's gone. So this replicator absolutely is keeping things in sync. Of course, I don't want to just be running some script on some EC2 instance somewhere. I do actually want to deploy this into something long-lived. And so this is where we're going to come back and do our Copilot going on here. So if I go into the Copilot directory, I'll see where it created a manifest for my application. The application is called DocumentDB Replicator. I want to give it a little more memory, okay? And I also want to define some environment variables that are going to run here. So if I see what's here, I want to give it some more memory and CPU. And I need to give it my new endpoints so that it knows how to talk to DocumentDB and how to talk to Elasticsearch. You know I'm legit because I'm using VI in a demo. All right, so I have this manifest file now, and I just want to deploy that application into Fargate. All right, so I'm going to do this Copilot command to deploy my service. All right, it's going to build the Docker image, which, by the way, the Docker file is really simple. We can Control+ it here. Again, I look at the Docker file. It's very simple. It's just a few lines. It's based on the Python image, since it's a Python project. I add it to /temp. I add the requirements file, which again only has just a few lines in it, and then I install the requirements, and then my command is just to execute that Python script. So it's great because if the script happens to die, or the Fargate instance that it's running on happens to be taken offline, Fargate will automatically restart my script. The replicator will take off, where it was before, and it'll keep going that way. So that's as easy as it is. We've hit our 1 hour limit here. I'm happy to stick around for a minute or two, but as soon as this deploys, I'll be able to watch the logs of it as well. If I want to tail the log file for it, I could tail the log file for it. It doesn't exist yet because it hasn't been deployed, but essentially I can just say Copilot service logs for this is the name of the service, DocumentDB Replicator, and then I'll follow those logs, and and it'll tail the logs for me, which are coming from CloudWatch logs. So
very cool. And we see this as a really common scenario on DocumentDB. and DynamoDB as well. I mean, just having the ability to do fuzzy search and Elasticsearch over your operational data is a very common pattern. So it's a really cool demo and something that's really useful.
Yeah, absolutely. I think this is a very strong combination, using DocumentDB as your primary data store with something like Elasticsearch as a secondary index, where you can do full text searches and geospatial indexing and things like that.
Yeah, we see this a lot in retail, especially like, hosting product catalogs where, you want to have all your metadata. Think about Woot as a use case, right? You want to have all your product metadata, but you also want to be able to enable customers to do fuzzy search over product descriptions. And that's kind of a better together scenario for these types of applications. We also see this a lot in kind of the web publishing and media space as well, where quite a few customers running this pattern.
So it did launch. I can tail the logs and see the logs happening here. I'll insert something just to prove that it works. We should see that come through here. It's probably not existing here yet. Yeah, it did get replicated. So Foo2 does exist now. So it is working.
Cool.
All right. And then when I want to clean it up, never remember the command, but Copilot app delete, and I'll delete the Twitch application. So that'll go clean up, all the things that it created for me in the back end. That's as easy as it is. It's so easy to deploy a long-running process in Fargate, and I want to thank our friends at Containers from the Couch for helping me do that. All right, we've reached the end of our time, and so I do want to tell you that we're going to be having this show bi-weekly, every 2 weeks. The next show will be the same bat time, same bat channel, 8 a.m. Pacific, 11 a.m. Eastern on October 22nd. I'm your host, Chad Tyndall. I've been joined by my co-host, Joseph. I can never say his name right. You're going to have to show it in the next episode. How do we say it? Joe.
Joe is just good enough. I mean, it's darn near impossible. So I'm just your average Joe. Just Joe.
You're not average. You are one standard deviation minimum above average. Thanks, everybody, for joining. We'll see you in 2 weeks. Please come with your questions. And
thanks, Chad. Thanks, folks.
Looking forward to it. Thanks, everybody. Bye-bye.
All right.